Um, I've been working on these all day, trying to figure out how to produce the matrix form of a magic hybrid number cube. And I think I figured it all out. This is what I started on earlier today, and there's different colors for the primary numbers blue, and for the secondary numbers orange. And these are some more, but with the um, inner and outer ghost numbers at the bottom. These are matrices, by the way. And this is the final one before I finally realized what was going on. And right here, I have a blank cube, and I'm going to try to show you the combination that I use, the combination of methods that I use to fill out the cube without the cube to assist me. Only starting out with the 3 input primary numbers and the central real number, 6 in this case, and 4, 2, and 7. So here's the method I did. This is writing them out in matrix forms. This is a primary intersecting matrix because it has primary numbers. It's primary and central real number, 6. Only color the ones that in this matrix, I only colored the ones that I used to fill out the rest of these. And I colored these because these are the central real numbers, 6, 6 on 3 different plane lines. Okay, so you start out with what I chose, 7, 2, and 4, with the central real number 6. And you put 6 down here for these because these are all intersecting number lines, equations. 7 plus 6 is 13. 2 plus 6 is 8. 4 plus 6 is 10. And outside, it's still the commutative property. 14 on both sides. 4 plus 10 is 14 on both sides. 2 plus 8, 8 plus 2 is 10 on both sides. 7 plus 13, 20 on both sides. 13 plus 7. So now this is the next cube, the secondary numbers. They would be in orange, and the primary numbers would be in blue, but I didn't want to cause any confusion. So I just wrote them in black to show I wanted to show the initial numbers I started out with. So you get these combinations. These are actually combinations of the primary numbers that you start out with. And 2 and 4 is 6. 4 and 7 is 11. And 7 and 2 is 9. And with this structure of a cube, these are the only combinations you have here, 6, 11, and 9. But these are the secondary numbers. And as you can see with these green lines and these yellow lines and these brown lines, they bounce off the central real number. And there's 2 different equations that bounce off and complete the main equation on both sides. So 6 plus the central real number is 6 is 12, plus the central real number again because you're bouncing off. It's 18, and it's 24 on both sides. Because 6 and 18 is 24 on both sides. And 12 is half of that. Now I'll get to that in a second. Then you have 11 plus 6 again, the central real number is 17. Added to 6 again is 23 because you're bouncing off of it for the secondary numbers twice to get the outer ghost numbers, or the outer numbers. 34 on both sides, 11 and 23 is 34, 17 is half of that, and that'll double up on the cube. That's another rule for this method. Then 9 plus 6 is 15, 15 plus 6 again, because you're bouncing off it twice, is 21. The outer numbers is 30 along these planar matrix. These are the equations, secondary number equations that make up the planetary matrices. Altogether, these form this planetary matrix, 3 by 7. This was a 3 by 5, the primary and intersecting matrix. Then you add these two together, the outer numbers, because you're really adding up the shell, which would determine the outer ghost number. Really adding up the outer shell. You get 14 plus 10 plus 20 is 44. 24 plus 34 plus 30 is 88. And you add those together, you get 132, which brings you to the diagonals ghost number, inner and outer diagonal ghost number matrix. And you put the outer ghost numbers on both sides of these diagonals, and you determine that the diagonals by, this is the purple right here, you add this to this, and that gives you 39, and you can subtract 132 from 39 to give you 93. That's the other for the diagonal that goes down this way. And then you add these to these. That gives you 75. And you subtract 75 from 132, and that gives you 57. And it's the same way this way. You have, this is a special type of equation, and it only produces like 18 small to large, and the other three are duplicates going in these directions. So you have 39 here, 93. So I can go and fill that out. 39. Well, 39, 93, and 57, 75, 57, 75, and 57, 75. Then with these secondary numbers, these are plentier. So you know the 6 is right here. 4 plus 2 is 6. And you know right here 7 and 4 is 11. And 2 and 7 is 9. So you can go right here and complete based on what these show. So across from 6 is 18.